type of polymers, if you are talking about the classification, I wanted you to take here. Okay, the same thing I have reproduced. You can go through it later. The classification of these polymers. Basically, we have four important classification based on the origin of sources, the natural polymers and semi-synthetic and synthetic polymers. Based on the structure, linear polymers and branched polymers or cross-linked polymers. Based on the molecular force, okay, elastomers and fibers, thermoplastic and thermosetting polymers. So these already directly we have studied these based on the molecular forces, elastomers and the fibers and the thermoplastic and thermosetting polymers. The thermoplastic and thermosetting polymers, we know the main important differences between them. The thermoplastic, we can remold them many times by heating. The thermosetting, once it is set down, it's not possible to repeatedly heat up because they will not get the quality of what the polymers have to be after melting. Okay, based on the mode of polymerization, additional polymerization and condensation polymerization. So these are the very important, the brief classification of these polymers. Okay, the basic classification of the polymers. Then after this, let me try to understand these different polymers, ABS, acrylamide and butanide and styrene, and PLA and PC, polycarbonate, and polyamides, that is the nylon and nylon. It is the grade of again the nylons, and glass-filled nylons, and epoxy resins and wax and photopolymer resins. So these are the different the polymers we'll come across. Okay, and these polymers, as I told you, their nature are natural characters. In other words, we can say polymers, they are having the long chain molecules. Okay, and they will be produced by linking the small repeated molecules. That means the small monomers. Monomers are those. These are the individual molecules. Monomers are the individual molecules, and these repetitions will be done by making a polymerization. Polymerization means linking together different monomers together. It will be forming the monomerization, or in other way we can say it is a polymers. Okay, monomerization or polymers. The polymers, the repeated chain which will be repeated, that will be helping you for many other applications. Those kind of things will be used. Okay, and the polyamides. The polyamides are again the repeated chain links all these. Okay, by amide bonds, CONH linkages. Okay, and they are available in the naturally or even the artificially we can generate them. Okay, and the natural polyamides are such like wool and the silks, and artificial polymers are the nylon and aramide and sodium poly. And I don't want you to understand the chemical reaction of these and how they will be produced. How they can be used in this additive manufacturing is very important, rather than understanding the basics of all this. Okay. Now, what are the advantages of polymer and EM techniques? How they will be helping, or how they can be resistive, or how they can be used in this additive manufacturing technology. We'll try to understand them. And they have all these polyamides have the high mechanical strength. High mechanical strength in the sense after molding. Before molding, they'll be in the form of a powder, and these monomers will be by means of some other way they will be made into a solid wires or some other plates like structure, a strip like structure or wire like structure or fiber structures in order to go for the next molding. And after the molding, they will be having very good mechanical strength, so they can be used for the prototype development as well for the physical prototypes also. There are two types of this one, physical prototype. That means prototyping. It is directly we are going to use for the physical operations, and the only the look prototype, which will be only it will not be having much more applications rather than in the design process. Okay, and these polymides will be having very good mechanical strength. They can retain their shapes for a long time, and high toughness. They'll be having very good toughness. Okay, and high softening point. High softening point is very important thing, because once it is heated up uniformly, it has to soften itself so that the flowability can be very good and you can able to laminate one or the other. That is very important character. And good area resistance, they cannot wear so easily, and they'll be having very good self lubrication. This self lubrication is very much important for flowability of these polymides while they are flowing through the nozzle. Okay, they'll be having self lubricant, and they can the long term work at high temperature. Long term work at high temperature in the sense at very high temperature, they can retain the structure, and even for long time, if you are going to stabilize the temperature at that particular stabilized temperature, they can retain their positions. Okay, that is what the long term work at high temperature. And excellent electrical insulation, low smoke, low toxicity characters. They are very good resistant to the electricity, and they produce very low smoke. The smoke will be developed when it is heated up, when it is coming to the liquid state, or when it is going for solidification. What happens is some kind of smokes will be developed. The smoke generation will be very less in case of polymides. And low toxicity. They are very low toxic in nature, and all these characters makes them to be very much suitable for the additive manufacturing. Okay, these are very important advantages of having these polymides. And now PF resins. The PF resins are the synthetic polymers obtained by the reaction of phenol and substitute phenols with polymers. Okay, and these are the different this one polymers and polyformadiene and polyesters. All these are the different this one polymers. They'll be often used based on the nature. They'll be very much useful for the specific applications. Okay, this.